All right, hello everybody. We're going to look at lesson 18 here. So what you want to do, you want to open up the lesson. Might be helpful to have the lesson slides open, and then which pretty much will always be the case from here on out, you'll want to have the periodic table open. So basically what we're going to do is we're going to learn more trends in the periodic table. So as you go through each slide, I would suggest, guys, if you have the ability to print this off, have a hard copy of this. That way you can start writing on it. It'll make your life way easier if you can start writing on this. So like I said, print it off, have a copy. Let's go. If you have one, if you look, like, for example, what's going to be helpful, I might even refer to this during this lesson, is have something like this, have something like this one right here, where you can see where the metalloids are right here. Remember how the metals are starting from the first column all the way over to the gray that's underneath this like stair step looking thing. From here all the way over to here, these are all the metals. This little strip right here is the metalloids, and then everything right here, this upper corner, is the non-metals. You're going to need to keep track of that for this lesson, and I think you'd be much better off if you take this periodic table we have, print this off. That way you can shade in which ones are the metalloids. It'd make your life a lot easier on this. As we go through this, if you want to label stuff on your periodic table, you can do that, and it will help you. So first off, we have hydrogen, which is kind of in a unique situation. Even though it's in group 1, it's really its own family because it doesn't behave like anything in group 1. So it's almost like I don't know, what's the phrase? The ugly duckling or the redheaded stepchild, or whatever it is. It is in group 1, but it doesn't act like group 1 at all. So it's a gas at room temperatures, which normally is how nonmetals act, even though it's all the way on the left where the metals are. It's colorless, odorless, tasteless. So it's much different. It's what combines with group 17 to produce acids. And then we have group 1. So that's what I'm saying. It's where hydrogen is, but it doesn't act like anything else in here. So what I give you as a description for group 1 is everything with the exception of hydrogen. So group 1 are the alkali metal families. They form cations with a +1 charge. So these ones will typically get rid of an electron and have a +1 charge. They're conductive and they're low density. They're very soft and they give one electron away, which is why they get the +1 charge. These all fill the S sublevel. Okay, moving on, group 2 are the alkaline earth metals. These typically form a cation with a +2 charge. They have a slightly higher density than alkali metals, but they're much harder. And they give up their 2 S electrons when bonded. So what these do is they remove when they bond, they lose the 2 S sublevel electrons. So they are filling up the S sublevel. They have 2 in the S sublevel. So you might want to, there's multiple, this slide alone helps to answer multiple questions. So what I would probably do is have the slides open, the questions. I'm not going to answer all these for you due to the fact that literally all these answers are here in the slides. So this almost is you paying attention. So I'm not going to go over the answers at the end. I think that's reasonable because all of these are you paying attention to the slides. So I'm not going to give you the answers at the end. So make sure that you're paying attention, and I would fill this out as we go. Next, we have groups 3 through 12. So this whole dip right here, where it dips down here all the way over to right here, this area is called the transition metals. And so the transition metals, we call them the D block because everything there is filling up the D sublevel. That's why you'll notice that there are 10 columns because there's 10 electrons in the D sublevel. These are hard, dense, conductive, they're magnetic, and their reactivity depends on the electron configuration. So you'll see gold is not very reactive, while copper is. Now, an extra detail is that in the 6th and 7th periods, really right here and right here, notice it has that kind of block, and it says 57 through 71. And then right here it has a block, and you have 89 through 103. So that is called the inner transition metals, and we moved them to the side because that way they wouldn't throw off the rest of the patterns in there. So these things, the top row is called the lanthanide series. So this row right here, this 57 through 71 is the lanthanide series, and this one down here is the actinide series. And most of them they're not even found in nature. A lot of them were produced in labs, and they're extremely reactive, and that's why, in fact, the actinide series, it produces tissue-destroying and cancer-producing particles because of how reactive they are. Okay, then we have group 13, very creative name. It's called the boron family, which is just boron is what's on top of group 13. And this consists of the post-transition metals. So this is the metals right after transition metals. And the physical properties of these is they are metal-like as their atomic number increases. The reactivity greatly differs. And this is the first group that's filling up the p cell level. Group 14, carbon family. This has one nonmetal, which is carbon, and then it has two metalloids, and then it has three metals at the bottom. They're all solid at room temperature. They're a little less reactive as you go down the group. So the one on top, carbon, is the most reactive. These are also filling up the p sublevel. And then the nitrogen family, these they have a wide range of properties. Just because this family consists of some metals, nonmetals, and a metalloid. So nitrogen acts like is in a gas, while the rest are typically solid. And like I said, the chemical properties vary greatly, and all of them are filling up the p sublevel. Group 16, once again, just named after what's on top of it. And so we have the oxygen family. And so, once again, they have metals, metalloid, nonmetals. Their properties greatly differ. And oxygen sulfur are very reactive. They form what we call oxides and sulfides. And this group is filling the p sublevel. Second to last group, the halogen family, they all act very similar. Every single one of these are extremely reactive. This is because they're about to get their last electron and fill up the p sublevel. So they're at 7, and they want to get to a valence number of 8. And then lastly is group 18. These guys have arrived. They have 8 valence electrons. Their electron shell is full. They are completely satisfied. And so they have full electron shells. And so we actually originally called them the noble gases. The reason that they're named the way they are, for example, there's an element argon in there, which is Latin for the lazy one. And the reason is because it's so unreactive. We called them the noble gases because we're talking about Europe during some of the scientific revolutions, where the aristocrats, the noble class, never would interact with any of the common people. So the scientists named group 18, named this the noble gases, because they're so noble they won't interact with the rest of these elements. They're unreactive. They're the most unreactive group on there. And this is because they have 8 out of the 8 valence electrons that they want. So they don't need to lose or gain electrons. They're happy with where they're at. And these are also filling up the p sublevel. So when you do this, you know what? I will give you some up with this. Which groups have no nonmetals? If you want to pause it and look at this to do this, remember nonmetals are up here. It's everything up and to the right of these metalloids. So that gives you all these groups that have no nonmetals. That's how you answer those questions. Which group has one nonmetal? So look at them. Which of them have one nonmetal? This was also discussed in the group. So this is you'll need a periodic table like this to figure this out, unless you can print this off and shade in the metalloids. Look at what's here, shade in these metalloids. Then it also makes it easy to use your periodic table to answer that. But go back, look over the slides if you need to. Rewatch part of the video, and you should have no problem answering these questions. These questions will help you determine that you understand this stuff. Email me if you have any questions and issues as always. And know that this is going to be the last lesson before we take a test. So we'll review the last few lessons, and we'll be taking a test this week. All right, you guys have a great day.